Hello, my name is John Owen and this is a short video showing various ways Barbacana's Full Monte can be used to quickly improve your chance of project success. In the next 18 minutes we will have a brief introduction as to why schedule risk analysis is beneficial to all projects, 3 different ways to capture estimates, how to view and use the results, and an example of modeling discrete risks in the schedule. Clearly, 18 minutes is not enough time to consider all the features of the product, but we do cover everything needed to complete your first schedule risk analysis. We are all too familiar with projects being delivered late. This unfortunately often happens even if project estimation and execution are actually very good. The reason for this is that the typical critical path CPM models we create do not consider estimate uncertainty. There is always some variance between estimated and actual duration, and an effect called merge bias reduces the chance of successors starting on time. To improve our forecast for the future, we need to consider the effect of uncertainty. Full Monte implements Monte Carlo simulation that allows us to simulate the execution of projects thousands of times to understand the effect of uncertainty. Uncertainty includes estimate uncertainty and discrete risks or threats that may or may not occur. Rather than capture a single point estimate for task durations in the future, we can capture a range of possible values, often known as a 3-point estimate. One of the best ways to quantify estimate uncertainty is to analyze past performance for similar types of work. If this is not possible, then informed guesses will have to be made. Here is an example of a project that is partially complete. The blue bars represent actual dates and the green bars are the baseline dates. We can use the Full Monte history view to compare estimated versus actual durations and prepare graphs to help guide and justify assumptions regarding future uncertainty. I will launch Full Monte and open the history view. We can see the graphs available at the various summary tasks. Here I am opening a graph at the top level of the project structure. We can see that the various results are varying between under 50% of the estimated duration and up to 660% of the estimated duration. The most likely result is actually very good, and 33.6% of tasks finished in their estimated duration. Obviously, it is concerning that more than a few tasks appear to be overrunning by significant margins, and the history view allows us to drill down to investigate. Possible reasons could include data entry errors, very short duration tasks taking longer than expected, or as is the case here, for the tasks overrunning by 660%, a risk occurred that had not been identified and mitigated, and subsequently had a major impact on the project. Setting aside the extreme values, we could use this data to justify future uncertainty in the range optimistic best case, roughly 50% of the estimated duration, most likely at 100% of the estimated duration, and pessimistic worst case around 200% of the estimated duration, while the shape of the histogram resembles a beta curve. Having determined how uncertainty has affected past work, we can now apply that information to the future. Here we have a small example of future planned work. The schedule comprises 3 components: a hardware component, a software component, and a brochure for our final product. The critical path runs through the hardware components, and the schedule is forecasting a finish of April 6. We call this the deterministic finish because it does not consider uncertainty and is based on single point estimates. Now let's open Full Monte and apply the uncertainty ranges from our historical analysis. I'm going to set the distribution type to beta. and the most optimistic or best case duration for all the tasks at 50% of the estimated duration. The most likely duration is going to be 100% of the estimate, and the worst case or pessimistic duration set to 200%. We are now ready to run our first risk analysis. I'm going to run 10,000 simulations. Run as many simulations as you can in the amount of time you're prepared to wait for. The more simulations, the better. And then we can view a graph depicting the probability of the project finishing on various dates. Here we can see a range of histogram bars. The height of the bar indicates the number of simulations that finished in any particular time period. We can see here in the title that Full Monte is predicting we have only a 9% chance of delivering the project by April the 6th. We have a 50% chance of being able to deliver by April 19, but in reality we are going to want to commit to forecast dates with a higher level of confidence. Many organizations aim for an 80% of confidence in the dates that they forecast, and in this case that would mean we have an 80% chance of finishing on April the 27th. It is unusual to forecast at 100% confidence because, as you can see from the date ranges here, because of the long thin tail to the histogram, there is quite a large jump between April the 27th at 80% confidence and June the 4th at 100% confidence. Of course, the big problem with the software showing April 27 at 80% confidence is that we may have already committed to delivering on April the 6th. We are going to have to rework the schedule to improve our chances of reaching that goal. Full Monte can help identify opportunities for schedule compression using sensitivity analysis, with the results often presented as a tornado chart. The tornado chart serves three purposes. Firstly, it shows us the tasks creating uncertainty in the project delivery. Secondly, it shows which tasks tend to improve the average project completion when they finish towards their optimistic best case duration, the green component of the bars. And thirdly, it provides a sanity check that the major components we expect to drive the schedule are in fact included. In this example, I can see that 4% of the time the brochure development delayed project delivery, something I never want to happen, and that hardware tasks 1 and 4 appear to offer the best opportunities for schedule compression. Can I reduce their durations by using more or better resources? Can I improve my estimates and reduce uncertainty? Or can I change the logic of the schedule so they have more slack or float? In the previous example, we applied a single set of historical uncertainty to all the tasks in the schedule. This implies that we consider all tasks equally risky. In practice, this is rarely the case. Many organizations employ risk workshops to assess their confidence in the various task duration estimates and to identify potential threats or risks. Full Monte allows assessment of confidence in the task duration estimates to be captured in Microsoft Project. This information can then be loaded into Full Monte and used as the basis for the risk analysis. In Microsoft Project, I have added a column, a custom text field, to capture our assessment of the risk associated with the task duration estimate. The terminology is user configurable. In this case, I have categorized the hardware task durations estimates as low risk. We have high confidence in the estimate, and the software tasks as high risk, low confidence in the estimate. In Full Monte, I can define what the various assessments mean in terms of duration uncertainty using templates. The default template is configurable by the user and defines the initial uncertainty applied to new projects. Here is my template for the high risk or low confidence duration estimates. Tasks identified as high risk will have a triangular distribution with the optimistic best case duration set to 95% of the estimate, the most likely duration set to 110% of the estimated duration, implying we usually overrun on such work, and the pessimistic worst case duration set to 150% of the estimated duration. I can then apply the template uncertainty based on the assessment in the schedule. We can then run a risk analysis based on the assigned uncertainty. Once again, the graph column has been populated and we can review the histogram for project completion. In actual fact, compared to the original historical uncertainty we applied, the chance of finishing on April the 6th has dropped to just 1%. The 80th percentile or 80% confidence date is now April 18. Full Monte always calculates all of the charts for all of the tasks and summary tasks in the schedule. This chart represents project completion. I can look at individual milestones. For example, here is the hardware complete milestone. I can also go back to the tornado chart to see the tasks creating the most uncertainty in the outcome with the revised uncertainty. You will note that certain tasks are no longer displayed, for example, the brochure, integration, and so on, and in our model we did not provide uncertainty estimates for those tasks, so they will not appear on the tornado chart. I can also focus the tornado chart onto specific delivery milestones. For example, here I can focus the attention onto the hardware completion milestone. And now only tasks creating uncertainty in that particular deliverable milestone in the schedule will be highlighted. I can see here that hardware tasks 1 and 4 are creating the most uncertainty in that particular milestone. The hardware Task 1 is on the critical path to project completion 18% of the time, but 100% of the time it is affecting the hardware completion milestone. Another way to load uncertainty information into Full Monte is to use duration custom fields in Microsoft Project to capture your discrete duration estimates for optimistic, most likely, and pessimistic. In the example on the screen, I have defined that the 4 software tasks are going to have a triangular distribution with a most likely duration based on the estimated duration in Microsoft Project and best case, worst case durations that I have manually entered. I can load that information into Full Monte by using the file import capability. And we can see here in the edit screen that the revised discrete estimates have been imported into the model. And again, we are ready to run a risk analysis. Not only are results from the Full Monte risk analysis visible within Full Monte, but they can also be saved back to the source scheduling system, be it Microsoft Project or Primavera P6. When I close Full Monte, I do have the option to save results, and this will have populated some additional columns that I added to my view in Microsoft Project. So I have the start and finish dates at the 80th percentile saved into custom duration columns, and I can then use that information as a bar style in Microsoft Project to draw a risk-adjusted Gantt. During the risk analysis, Full Monte calculates a risk path number that can be used to group tasks by their criticality to the sensitivity target selected on the risk analysis dialog. Again, this facilitates custom charts in Microsoft Project or Primavera P6. In the example here, I can see that the primary critical path including uncertainty that is driving the delivery of the project, goes through the initiation, software task 1, 2, 4, software complete, integration, and delivery. A secondary critical path, based on the criticality during the risk analysis, would go through software task 3. A tertiary critical path, again based on the uncertainty, would go through hardware task 1, 2, 4, and hardware completion, etc. So far in this video, we have focused on modeling duration uncertainty. However, full Monte can also model discrete risks or threats and risk mitigation using several techniques including task existence, probabilistic branching, and conditional branching. Task existence is used to model simple threats that can be represented by a single task. Probabilistic branching can be used to model more complex threats or opportunities, and conditional branching is most often used to model risk mitigation. In this example, I have a simple 4-task project. We're going to make something, test it, and then we, based on historical information, know we have a 20% chance that we'll have to do some additional work before final delivery. In full Monte, I can use the task existence feature to specify that the repair work will only occur 20% of the time. For the remaining 80% of the time, the repair work will be considered as zero duration. And then I can look at the histogram for project delivery, and we'll see what we consider a bimodal distribution. So 80% of the time we are delivering around June 5, whereas 20% of the time, based on the additional repair work that needs to take place, we are delivering around June 19. Schedule risk analysis is a technique that will enhance your ability to meet your commitments to your clients. It can also reduce project costs by enabling you to be more prepared for what might happen. Please let me know if you have any questions, or you can download a free trial of the software from our website. Thank you for watching.